This video is for Math 70, and this is a follow-up assignment on parallel and perpendicular lines. These are the symbols for parallel, and this is the symbol for perpendicular. Okay. And this is the fundamental idea, is that parallel lines have the same slope, they're equal to each other, whereas perpendicular lines have slopes that are negative reciprocals. So if one line is like y equals 5x plus 7, a line that's perpendicular to it would have a negative reciprocal slope. And it may have a different y-intercept, but that doesn't matter. What's important is the slopes. Okay? All right, so that's the fundamental idea for doing this assignment here. Well, let's look at some examples here. Problem 2, we want a line that passes through, so let me just try to, through the point 0, -1, and parallel to y equals 3x plus 2. Okay, so right away, since we're looking for a parallel line, it's going to have the same slope, so it's going to be in the form y equals 3x plus something, right? We don't know what the y-intercept is. To find the y-intercept, we plug in the x and y values that we know. I'll draw a graph of this in just 1 minute. The y is -1, the x is 0. In fact, this problem gives you the y-intercept as -1. We don't really have to calculate here, right? Because this is going to be 0, b equals -1. So our answer then is y equals 3x minus 1. All right, let's draw a graph and see what's going on. Y equals 3x plus 2. Here's the y-intercept at the point 0, 2. And then if we go up 3 and over 1, this line will look something like that. Now, we want a line that passes through the point 0, -1 and is parallel to this line. And there it is right there. That's the line y equals 3x minus 1. This is the line y equals 3x plus 2. This is just for demonstration, for your benefit, to help you visualize what's going on. The answer that we're looking for is the equation of this line right here, the parallel line passing through the point 0, -1. Okay, so that's problem 2. We'll go through a few more of these. And let's see, I think I'll erase this example right here. Okay, problem 4. Passing through the point 0, 3 and parallel to the line y equals -2x plus 4. Okay, so again, if it's a parallel line, it'll have the same slope. The slope is -2, so the line that we're looking for is going to be in the form y equals -2x plus b. Okay? Now this turns out to be the y-intercept, 0, 3. Okay? So I can jump down to the answer here. Y equals -2x plus 3. All right? In problems where we don't have the y-intercept, you can plug in the x and y values and then solve for the value of b. This is the answer that we're interested in right here. Okay? Now again, just to give you an idea of what this looks like graphically, here's our original line, y equals -2x plus 4. It's going to be something along these lines. And the line that we're interested in is going to be y equals -2x plus 3. That's the line that we want. Okay? All right. Let's keep going with these. Okay, problem 6 is the first one we have that's perpendicular. So we want it passing through the point 2, 3 and perpendicular to y equals 1/5 x minus 4. Okay, so now with the perpendicular lines, their slopes will be negative reciprocals. So if we want something that's perpendicular to this line, its slope will be negative 5/1, right? This is a positive 1/5, and so a line that's perpendicular to it will have a slope of negative 5/1. And then we don't know the y-intercept, so I just put b in there. And then we're going to substitute in for the x and the y. And then solve for b. And so here, b is going to be 13. So the answer that we want, y equals negative 5x plus 13. What does it look like on a graph? And this is not part of the problem. You don't have to graph these. I'm just doing this to try to help you to visualize what's happening. 1/5 x minus 4. There's the y-intercept there. 0, negative 4. Slope of 1/5 will look something like that. Now this point passes through the point 2, 3 and is perpendicular here. And so there's our slope, negative 5 plus 13. There's our y-intercept up there at 13. This is the line that the problem is asking for the equation of. And you can see how they're perpendicular right there. That makes a 90-degree angle. Okay, that's problem 6. Okay, problem 8, another perpendicular. So it's passing through negative 1, negative 1, and we want it perpendicular to y equals negative 3x plus 4. Okay, so again, perpendicular line will have a slope that's a negative reciprocal. So this is negative 3/1. And so the slope of the line perpendicular to it will be positive 1/3. All right, so now we need to plug in our x and y values. Negative 1, negative 1/3 plus b. Add the 1/3 to both sides. b will be negative 2/3. And that's fine. If you don't get a whole number for the y-intercept, it's not that big a deal. Y equals 1/3 x minus 2/3. And we'll look at the graph. Let's see, negative 3x plus 4 is going to be something like this. And then let's see, the other one. Well, we want it to pass through the point negative 1, negative 1. That's going to be about here. And then perpendicular to this other line will look like that. Let's see here. Oh, that's what I did. So I made a mistake here, right? Because it says the y-intercept is negative 2/3. That's down here. My y-intercept is up here. So what did I do wrong? This point is wrong. This is the point negative 1, positive 1. The point negative 1, negative 1 is right here. And if I put that point in the right place, and then draw a perpendicular line, there's our y-intercept at negative 2/3. And here's our line, which is the answer, y equals 1/3 x minus 2/3. Okay. All right, let's see, that's problem 8. Problem 10. It's a little bit different because the equation is not in slope-intercept form. So let's take a look at that one. So problem 10 is passing 6x plus 3y equals 8. All right. So, if your equation is not in slope-intercept form, we need to get the y by itself. Okay? So, let's move the x to the other side. 3y negative 6x plus 8. And then divide everything through by 3. Y equals negative 2x plus 8/3. So there's our slope, negative 2. So that means the line that we're interested in, since it's parallel, will also have a slope of negative 2. So, y is negative 2x plus b, whatever the y-intercept turns out to be. And to find out what that is, we need to plug those x and y values in. Y is 1 when x is 5. Okay, so negative 10 plus b, add 10 to both sides, b equals 11. And so the line that we're interested in is y equals negative 2x plus 11. Let's see what it looks like if we graph it. Let's see here. So, a y-intercept, this is 2 2/3, so we'll put that right about here with a slope of negative 2. And then the line that we're interested in is going to be parallel to it, passing through the point, let's say 5, 1. It's going to look something like that. And this is y equals negative 2x plus 11. And yeah, it does kind of look like the y-intercept there is going to be about 11. Okay? So this is just a way to kind of see what's going on. Sometimes I like to do it. I did it on that last problem, and I caught a mistake that I had made. Although actually it was just a mistake in the graphing. My answer was correct. But when I went to graph it, I made a mistake. All right. Let's keep going with these. Let's see. Problem 12. This one is passing through the point 3, negative 3, and we want it perpendicular to y equals 3x minus 1. Okay, so we've got the slope right here is 3. So a line perpendicular to that will be the negative reciprocal. So that will be negative 1/3. And we don't know the y-intercept. Oh, actually, the second line, let me use been using the red marker for these. Let's try to keep up with that. Negative 1/3 x plus b. All right. And then we plug in the x and y values. So y is negative 3 when x is 3. So let's see here. Negative 1/3 times 3, that should be negative 1. Add 1 to both sides. B is negative 2. And so our line is y equals negative 1/3 x minus 2. And then if we're interested in what does this look like on the graph, let's see, 3x minus 1 is going to look something like this. And then the other line, we want it to pass through the point, let's see, 3, negative 3, let's say that's down here somewhere, and perpendicular, let's see, something along those lines. My y-intercepts are a little bit too close together, but that's just because of the sketch of the graph. It's not exact. If I did this on a grid, then you would see pretty clearly this is the y-intercept at negative 1, and this y-intercept here is at negative 2. It's in about the right place. Okay? It's just a little bit off because I was estimating to make that graph. Okay. So again, you don't have to make these graphs. Really all I'm looking for is this equation right here that you can get through this process. Okay, let's see here. Problem 14, passing through the point -2, +4, and we want this parallel to y equals 3/4 x minus 3. Okay. All right, so parallel lines have the same slope, so the slope for the line that we're looking for will also be 3/4. So y equals 3/4 x, but we don't know what the y-intercept is going to be. So we'll plug in the x and y values from the point that it passes through, times -2. So 3/4 times -2 should be -1.5. Add that to both sides. B should be +5.5. And our equation is y equals 3/4 x plus 5.5. All right, let's see what this looks like on a graph. So this line, here's a y-intercept of -3. A 3/4 slope is going to be something like this. And then let's see, the point -2, +4 is up here. And so a parallel line, let's see, let's do this in red. -2, +4. And a line that's parallel would look something like that. And yeah, that y-intercept looks like it could be 5.5. And so there's our line, 3/4 x plus 5.5. Okay. Let's see here. Problem 16. Passing through -1, -1, just like problem 8. And then parallel to y equals -2/3 x plus 6. Okay, so parallel lines will have the same slope. So our line will have a slope of -2/3, but we don't know the y-intercept. So we'll plug in the x and y values that we've been given, and then subtract 2/3 on both sides. So what is that going to be? -5/3. -1 2/3. That's a 5 there. And so that means our equation is going to be y equals -2/3 x minus 5/3. So let's see what this looks like on a graph. -2/3 x plus 6, something like this. And then the other problem passes, the other line passes through the point -1, -1. And if they're parallel, it'll look a little something like this. -2/3 x minus 5/3. So like I said, that's 1 2/3. So that's, like I said, sometimes it may not look exactly like 1 2/3 here. But that's just because I'm doing a sketch rather than graphing on a grid. But it does work out. It's in the right place. It's just shifted a little bit. My scale may be a little bit off. Okay, so that's the line that we're interested in. Let's take a look at a couple more problems before we wrap things up. Problem 18. Perpendicular. So passing through the point 4, 2, perpendicular to y equals 3/4 x minus 11. Okay, so perpendicular lines have slopes that are negative reciprocals. So the line that we're interested in will have a slope of negative 4/3. And we don't know the y-intercept, so we can plug in our x and y values and then solve for b. So negative 16/3. So we'll add the 16/3 to both sides. And so b turns out to be, what is that, 22/3? Okay, so the line that we're interested in, the answer to the question, y equals negative 4/3 x plus 22/3. Well, let's look at the graph. Let's see what we've got here. Negative 11 down here somewhere. A slope of 3/4 will be going something like this. And then the other line passes through the point 4, 2, right about here. And we want it to be perpendicular. Okay? Now that seems about right. This y-intercept here is going to be about 7 1/3. That's a reasonable approximation of that. And there's our line, negative 4/3 x plus 7 1/3. All right, one more problem to look at, problem 20. Okay, so problem 20 is another problem that's not in slope-intercept form. So this one is passing through -2, -4, and perpendicular to 3x minus 4y equals 8. Okay, so we need to get this in slope-intercept form so that we can know what the slope is. All right, let's move this 3x to the other side. Don't lose that negative sign. It's attached to the 4y. Negative 3x plus 8. And then we have to go in and divide everything through by -4. So that'll make that positive 3/4 x minus 2. All right, so now we need a line that's perpendicular to this line, which means that its slope will be the negative reciprocal, or negative 4/3. And we don't know what the y-intercept will be. So we'll plug in the x and y values. Y is -4, x is -2. So that'll be positive 8/3. Subtract that on both sides. And let's see, it looks like it's going to be -20/3. -6 2/3. So the line that we're interested in, the answer to the question, y equals -4/3 x minus 20/3. Let's see what the graphs look like. So this first line that we were interested in has a y-intercept of -2 and the slope of 3/4. And then the other line passes through the point, let's see here, -2, I guess -4 will be down here, and then perpendicular to it will be something like this, -4/3 x minus 6 2/3, and yeah, that could be -6 2/3 down there. That seems like a reasonable answer, and there it is. Okay. So, that's just a follow-up on that first assignment about parallel and perpendicular lines. So we have had some real difficulties on campus this week. I don't know when I will get this video posted, We haven't had a computer network since the ice storm last Friday. There's a good chance that that will be fixed tomorrow, which is this Thursday, the 18th. And as soon as I've got connectivity, I will upload videos and quizzes, and I will make some reasonable deadlines for those instead of making them due this Sunday. I think, hopefully, assuming that the computers are working tomorrow, I'll start posting everything, and I'll put a due date on it of next Wednesday so that we have a couple extra days to work on this, and that should work out pretty well. So, anyway, as always, if you have any questions, please let me know, and I apologize if I haven't been able to help you out this week as much as I would like, but I don't have email on campus, and so I'm not really able to do Zoom or email or upload anything in the way that I have, but like I said, I'm hoping that this will be fixed tomorrow, and we can just move forward. Thanks a lot.